Hi everyone, this is a small video which I thought I need to make before I do anything else, and this is my analysis of Indian Railways catenary cable and my suggestions for improving the system. I don't know whether it's been implemented already, but uh, I thought um, this the, the discussions presented in that I'm going to present in this video are worth sharing. So that is my perspective anyway. So Indian Railways and catenary cables. If you have taken a ride in the Indian Railways with catenary cables that run on electricity, you will be shocked that such a perilous system has been designed. And I'm going to talk about why it is perilous and whether how it got to the way it got to and what could have been done. You are riding on an electric train that is made of metal. There is a overhead live electric wire. There's a metal rail that can conduct electricity. Designer fear. So anyone can be electrocuted. If you designed such a thing, you should be very sure that nothing bad is going to happen. And uh, only people who are sure of what they are doing would have done it. And for reinventors, it could be a really difficult task. And I am probably a inventor, so I am sharing my thoughts. So I'm talking about possible safety features. I don't know whether these are real safety features, but they are possible safety features. Empty or opposite poled capacitors for detection and circuit breakers for unexpected current. So assume that overhead cable snaps and it falls on the train, and certain parts of the train receive current or charge. Uh, that stops the electricity circuit for the that should trigger an electricity circuit breaker for the train. Um, so opposite pole capacitors will suck current um, faster than other parts of the train, other parts of the system. So the circuit breaker will function faster. So I don't know how circuit breakers work. This is my idea. Earthing of railway tracks. Catenary cable break detection by hanging two cable method. So if you look at Indian railways, there are two cables overhead. So if this is to make sure that if one cable breaks, other cable detects that there is a break. Manual and automatic lowering of pantograph. Power source. Pantograph is a power source. So pre-detection and signaling of broken circuits. So I don't know whether this is implemented and whether it's already there. So it is to show danger that is ahead. So reflection on design part process. Alternative designs. You, so you could have placed capacitor on each pole to get a store and trans and use energy. So assume that there are poles every 50 meters. Each pole can have a charge dispenser that makes sure that the motor is running. Uh, Motors frequently provided power. So you can store energy in a magnetic field. So you can as the so you can store it in an electromagnetic coil. So as the coil loses power, uh, as the coil as the electromagnet loses its magnetism, it will get uh, it will trigger current flow and that can be used. Current circuit on each pole to accumulate enough energy for transit to each pole. So instead of capacitors and stored magnetic field, you can actually have a temporary current that stores energy. And so cable on side of the track to prevent overhead failure. So instead of overhead cable, you could have put cable on the one of the side, on a pole on the side of the track. So you can have buried cable on the side of the track. So you can have buried cable that runs under the ground, and that is switched on and switched off as the train process. Mechanical batteries to store energy that needs to be that as the train moves from pole to pole. Among the above methods, method 1, method 2 are the best, and probably the last one, last bullet, I should have put it there. I thought of it later. So that is a correction that needs to be fixed. Last button is mechanical batteries. So basically a kinetic system. Electrification of Indian railways. So was electrification done by original inventors of electricity and magnetism? Was it reinvented by so when the first system that is set up is generally not the best one. So yeah, I explained to you it is not the best, but was it done by Indian? So why none of the better designs were implemented? So I've discussed what the designs are and why it wasn't. So was it designed by Indian as reinvention? So this, based on my bet, I think it was done by Indian, because person who knows electricity and magnetism may not have done it the right way. Modern electronics in Indian railways. So this the railway system seems to be aged. There is that I don't know how much electronics are being used. Even I'm not an expert on electronics. So this is a surprise I got. So that is the question mark. I searched Google for non-conducting metals to increase security for electric cars and electric trains. So it showed a search result for ferrite magnets. Then so author does not know how ferromagnets are made. So electromagnetic coils that have iron core are made, and whether there is anything special about the iron core. So if the iron core is not done correctly, another disaster waiting to happen for amateur scientists. Shocking. So another thing that could shock you when you play with high electricity. Current energy can be diffused by magnetic nature of material. So, so what does ferrite? As I searched for ferrite, when the results showed ferrite core, immediately realized you can make metal sheets that have random magnetic orientations, and so current energy will be dissipated quickly. So the idea was shocking. Someone thought of what I did not, and non-shocking. So that is my play of words. So author thought of electron tunneling based metal sheet. So where there is a specific sink for all the current that flows through a metal sheet. So that author had thought about it, and he might have thought he might have implemented not a oriented random magnetic oriented metal. So this is needed for safe metals for electric transport systems. So AC source but DC tuned metal. So that you met the overhead line is a DC source, but you have a AC tuned metal sheet as framework. Or overhead is a DC uh, AC source, and the metal you use is DC tuned. So okay, so again the question mark here is that I was surprised that you can make metals non-conducting by magnetic. fields, and I did not think about it. So this is a future direction, gyroscopic gear to log translation and rotation changes. Gyroscopic gears to log translations and rotation changes. So I'm going to explain this in the next slide. If you don't know what I mean, magnetic tuned oscillations to transport power through magnetic oscillations. So you have current electrons that transport energy. You can have magnets that transport energy. So as you build these wires, you can use magnets, oscillating magnets that transport power without loss. So gyroscopic gear braking in case of emergency. So you must have seen in EMU that it starts, there seems to be something rotating as the vehicle brakes. I don't know whether that gear is also a gyroscope. So this is a gyroscopic gear and gyroscopic braking. So this is a wheel, and this is axis, triangular axis, and these four are out of the plane rotating wheels, and this is another wheel, and this is the central axis, and only three are shown, fourth is buried, and this is a lever arm that is attached to a damper attached to the frame of the object. So this system will block rotation and translation if these wheels are rotating, because these wheels, these gyroscopes, these eight gyroscopes that are here, if they are rotating, and if this thing moves up and down, these things will amplify the stopping force, and so a train, so this can be a very easy shock absorber. I don't know. I'm not sure whether it can be a shock absorber. I'm not thought about it. So maybe I should have. So this is the idea I got, and it's somewhat of a random idea. I haven't thought through this whole thing. So you can implement this in three different rotations, three different orientations. So you can be use this for trains, ships, and planes to get from one point to another without GPS and things like that. So, okay, that is a discussion on that. So, to the blind scientists who are interested in working for Indian Railways or any other projects, and who are forced to reinvent, reinventing high voltage systems, high energy systems is scary. So, it involves risk, and you start with a small project and gradually build up. So you can build miniature models of what you want to build, and then ask someone to put it in a movie and make a big blast out of it, or have some fun. So avoid skipping steps. I want to warn you that education is a form of skipping steps. So skip up the struggle, fake news to prevent bad things happening. So for inventors, for the leader, um, chances of things going wrong are very low. But for a follower, because you are as staring the ass in front of you, uh, chances of things going wrong are higher, and things go wrong unexpectedly. So you make random accident videos, uh, which I call fake news, to make people aware of what can go. Uh, uh, People make think twice about what they are doing, uh, and rethink what they are doing. So this is a easy way to somewhat of a easy way. This is not going to eliminate errors. This is going to lessen the chance of errors. So acknowledgements. Author had read books on capacitors and inductors. He had 12th grade Rusnik and Halliday, 12th standard, 12th grade Rusnik and Halliday, and entrance exam books for IIT JEE, problems in general physics by Rideau. So Indian Railways Thank I also want to acknowledge Indian Railways, electrical transport systems. Um, this is a complaint I had. Saw a European bullet train overturned while turning. I don't know whether it was fake news or real. So I was pretty scared. So the question is, uh, if it is not fake news, why a R&D department or a safety inspection of someone who tries was not implemented? Anyway, so please like and subscribe to my channel. Uh, Thanks for your time.